That's not good. Okay, so what we're looking at here is a rectangular mirror. Can you close the computer? A rectangular mirror has a perimeter of 260. So for A, the length of the mirror is X, the height of the mirror in terms of X. So what we need to do is we need to use this equation so for A, let me start again. For A, we say that 260 is equal to 2 times X plus H. So 130 is equal to X plus H, which means H is equal to 130 minus X. So B, find an equation for the area of the mirror, A, in terms of X. So the area of the mirror is going to be X times H. And then we can insert, instead of H, this expression, 130 minus X. And that's going to give us 130X minus X squared. Plot a graph of the equation of the area, showing how the area A on the y-axis and X on the length axis. Choose a suitable domain and range. So we need to use our calculator for this bit. Plot it on your calculator. Doesn't matter which way around you do it. It'll be the same. Sorry, can I ask for quiet, please? I can't hear what Sam was saying. No, it's going to be an expression because it's going to vary according to how long X is. The only thing that's static in this one is the perimeter. So if we graph this, it's going to look like this, and it's going to be really hard to see what the values are. We're going to need to change our scale a bit. So we put this one up to 100. Still not seeing it. Let me put this one up to 100. Still not seeing it. Going to put it up to 1,000. It's starting to appear now. Put it up to 10,000. 1, 2, 3. Oh, there we go. So if we look at what the maximum value is on the graph, have a go at graphing this on your calculator. We can see that the maximum. Sorry, let me just share that with you guys here on the front. Okay, so we need to graph this. We have the function, we just type the function. We're at the point for question 3, for part C, where we have A is equal to 130x minus x squared. We want to graph this. This is a difficult graph to draw. So I'm going to pull up my graphing calculator. You're going to add a page, add a graph page. And when we draw this graph, we get 100. Oops, I'm drawing in the wrong place. We get 130x minus x squared. Look at it going straight up. So when it goes straight up like that, we need to find a value. So if I put in 100 here, it's still just going up really, really quickly. So I'm just increasing the scale here till I figure out the sort of shape of the graph. I can see it going up a little bit more. Let me do the x-axis like that. I'll put it up to 200 there. I can see it's coming back down again by that point, so 150 will be enough. Let's keep increasing this. We're at 1,000. I think if I go up to 5,000, there we go. So it's quite difficult to see the shape of this graph. What will be a suitable domain and range for the function? What we need to do is we need to analyze the graph a little bit, and we need to find the maximum. So we can see the maximum here, but that's difficult to read. What is that number? Do you see the E? That means this is 4.23 times 10 to the power of 3. To get this off, I'm going to press Menu, Settings, and take off the float 3 there and put it to Auto. Let me see if I can get rid of that. And then go Menu, Analyze Graph Maximum. Nope, it's not giving me in non-standard form. Yeah, so it should be 423 or 4225. So I can see that the x value is 65 there, and I can't get the calculator to play ball on mine and give me the number in a format that I like, but I can go over here, pull up F1 and type in 65. There's the number that I want. So our range is going to have to be from 0 to 4,225. What would the domain of the function be suitable as? Well, we need to go from here. We need to find the x-intercepts for this one. So if we find the zeros, we can see that the next 0 is at 130. And I think you can see clearly that the first 0 is at 0, 0, but I'll just pop that one up there as well. All right, let me go back onto my pad now. I've got my diagram. Okay. Yes. Yes, please, just stop interrupting. Just take as long as you want. C. So in C, we're asked to plot the equation showing the area and choose a suitable domain and range. So in our diagram now, I say that the graph is going to look like this. It's going to go through 130, 0, 0, 0. And what was the maximum point? It was 65, 4225. Let me just check that. Yeah. What would the domain be? Would the domain be sensible as all real numbers?
Yeah.
Okay. So, what's going to happen to this graph if x is more than 130? It's going to continue like this, doesn't it? What would the y value be here? A negative number. What do we have negative area?
No.
What would the x value be here?
Negative.
So the length of one of the sides is going to be -1. That doesn't make sense, does it? When it comes to length and area, we can't have negative values. So this graph has to only be in the positive first quadrant, which is why I've drawn it like that. So what would be a sensible domain? Austin?
0 to 130.
Why?
That's not like the points. The 0 is like
That will keep the area positive. Yeah. So the domain is going to be from 0 to 130. Is it possible to have no area? Well, this one's a sort of moot point, whether you argue, yeah, you can have the idea of no area and no length seem possible. If I draw a line of no length, it looks like this. Nothing. So it is possible to have a line of no length and an area of no length. So you can include the endpoints. What would the range be? So it's going to go up to the maximum, but it's not going to go all the way to negative infinity. It's going to stop at 0 because you can't have less than 0 in the length. Okay. So D, we've done that one. We needed to do that one to do C, didn't we? State what are the two values that they represent. Well, those two values represent the smallest possible value of x and the longest possible value of x. So interpretation here for E, this is the smallest and largest possible values of x. F, hence find the equation of the graph's line of symmetry. So what's the formula for the symmetry line? We use the midpoint formula, don't we? Should we use this one? We could use minus b over 2a, but notice here it says, this is often a keyword used in exam-style questions, hence. And it means we need to use the result from the previous question in this method. So in the previous one, it says state what the two x values represent then. This is the x-intercepts. Then it says hence. So it means use your previous answer for this one. So we need the midpoint formula that we've been using, x1 plus x2 over 2. And that's going to give us the symmetry line is 0 plus 130 over 2. That's 130 divided by 2, which is that 65? Yes. We shouldn't necessarily need that. It's not much of a problem. We actually see it here, don't we? We found the x-coordinate of the vertex earlier. That's going to be the symmetry line. But it did ask us to use the previous results. Lastly, state what the equation of the line of symmetry tells you in this context. What does the equation of the line of symmetry tell us in this context? Nope. Vertex isn't in the context. What is the vertex? What is the context of the question? What does x represent? The length of the mirror. And what's special about the vertex? In terms of the range, what's special about the vertex?
The highest, the maximum.
So what does the symmetry, the context is about the size of a mirror, the area of the mirror. The area of the mirror varies. What is special about the symmetry line in terms of the context?
Is it equal to the side?
No? What's equal to what? It is. It is, but it's not what it tells you necessarily in the context. It is true. It is a reasonable interpretation. What is this question about? No. What is the sub? Is it? No. Do we have a function anywhere? We did. We made a function. Where is the function?
Y equals 130x minus x squared.
Okay. So our function is this. That's the function, isn't it? What is the A? Of what? Mirror. That's the context of this question. This question is about the area of a mirror. So, in our last part, we're asked to say what the equation of the symmetry line is. This is the length, 65, that will produce the maximum area. And that was 4225. So one of the questions in the major and the exams coming up is going to be interpret. Normally this question wouldn't be state, it would be interpret. And you have to interpret to do with the context, you have to interpret what it means. So our interpretation here in regards to the context is that the symmetry line, this is the length of X that will produce the maximum area. And then quote the numbers as well. All right, we are going to pause there for a minute. You guys need to get ready for, sorry, wrong one. You need to get ready. We're going to have a pop quiz.